Hey guys, welcome to lesson 2 on indices, our second lesson in week 2. Our goal today is to simplify expressions that involve negative indices. So as a warm-up, I've just got 2 questions here, A and B. Please take some time to do those. Take a photo and upload it to the relevant section in OneNote just so I can check to see how you're doing. All right, negative indices. Every now and then, if you think of a situation where we might have y to the power of 7 divided by y to the power of 8. Now, if you were to use your division rule, you would end up with y to the power of 7 minus 8, which gives you y to the negative 1. This is what we call a negative index, simply because the power is negative. If we ever see a case where we have a negative index, we are able to make it positive. We do this by taking the reciprocal. A to the negative m is equal to 1 divided by a to the positive m. And one really cool way to see that is on your calculator. If you think of 2 to the power of negative 1, that's equal to 1 divided by 2, or half, okay? And if you don't believe me, pop that in your calculator now. Sometimes that negative index ends up on the bottom. But that's okay, because just like we did here, we just popped it on the denominator and made it positive. Here, we're going to bring it up to the numerator to make it positive. So we're always going to do the opposite. So 1 divided by a to the power of negative m is equal to a to the power of m. These 2 really key index laws that should feel new to you this year. Not all classes would have gone through the negative index laws last year in Year 9. It is important as well that all of our final answers are written with positive indices whenever we're asked to simplify a problem with index laws. In our textbook, we're going to be asked very specifically to express our answer with positive indices, but in your exam, you may not be asked that specifically, but be expected to do so. So let's get stuck into some examples. So I've got 4 examples for us today. All right, they're in increasing level of difficulty. We've got A, B, C, D. Again, if you want to have a crack at these, please feel free to. If you think, yep, I've got this, absolutely jump in and have a go. We're going to incorporate the index laws that we learnt from last lesson, as well as our negative index law this lesson, in order to simplify these expressions. So let's get to it. The first thing I notice about A is that I have no common bases, so I can't simplify anything other than simplifying that negative 4. So I keep everything that's positive, or with a positive index on top, and I'm simply going to move that x to the power of negative 4 as x to the positive 4 on the denominator. And that's it. That's my answer. If I was to consider now this negative index on the denominator over here, just like in our law above, we're just going to bring that up to the numerator and make the index positive. In other words, this is going to equal 5x cubed. Now with part C, you have a couple of options here of which order you would like to work this out in. Now it doesn't actually matter which way you would like to work it out. You can choose to write 4 to the power of m. How about let's do both ways. Okay, option 1. We can recognise that there is a common factor there of 4. So we can pop a 2 there, okay, like this. That's going to be the same for both of them. And then on the next line, guys, what we can do is we can say m minus 2, and we can just use our divisibility index law and write m minus 2 minus 5, because there's a divisibility fraction bar in here. Minus 5, n 3 minus negative 4, all over 2. All right, if I simplify that, I end up with m to the negative 7, n to the positive 7, because 3 minus negative 4 is the same as adding them together, all over 2, and then I can simplify this by writing n to the 7 over 2 m to the 7. All right, so that's option 1. Option 2, all right, I'm going to erase this now. Option 2 is if instead we move the negatives to begin with. So on the, let's highlight those negatives. Got a negative m here, and we have here. So the first thing I'm going to do is on the numerator, I know I've got the n cubed there, but I'm also going to move that n to the negative 4 to the top with a positive index. Over 2, I've got that m to the 5 on the bottom. Now I'm going to move this m to the negative 2 down to the denominator, so it now has a positive index. And from here, we can use our multiplication rule to give us n to the 7 over 2m to the 7. So it's up to you which way you want to do it. When you do more and more of these in practice, you're going to find a way that vibes with you best. Whichever method you choose is absolutely fine by me, as long as you're showing you're working. This guy here is a bit of a cracker. So we want to consider this part of the expression separate to this part of the expression until we need to put them together, because they both require quite a bit of simplification. In both cases, I can see that they are all to the power of an index. So everything in this bracket is to the power of 3, and everything in this bracket is to the power of 2. So the first thing I'm going to do is I'm just going to bring that 3 to all of these 4 terms in here and to these 4 terms in here. So let's do that. I'm going to zoom in a bit here. Okay, so that's equal to 2 cubed, m to the 9, and I've just evaluated that straight away because 3 times 3 is 9. Remember, we have to multiply the indices when we bring that in. That's over r to the 6, n to the negative 12. And again there, guys, that's 3 times 2 is 6. 3 times negative 4 is negative 12. Divided by 5 squared, m to the minus 4, n to the 6, over r squared. Okay, cool. Now that that's out of the way, we notice here that we have a divided by a fraction. We're going to switch that to multiplying by its reciprocal. Let's do it. In that same process, I'm going to evaluate 2 cubed and 5 squared, because 2 cubed is just 8, 5 squared is just 25. Okay, let's do it. We have 8 m to the 9 over r 6 n to the minus 12 multiplied by r squared over 25 m to the minus 4 n to the 6. Now this is confusing because I've just switched that over and that 4 there is still negative. I haven't moved this. I haven't used my negative index law here. I've just multiplied by the reciprocal of whatever this was. Now in the next instance, I'm going to bring this guy here. I'm going to bring him to the top. Just make sure I don't bring him to the top because he has a negative index, and I'm also going to bring him to the top. In the same step, because everything is multiplied, I'm going to bring everything together. So this gives me 8m9 r squared. They were on the top to begin with. I'm bringing this guy to the top now and this guy to the top. All divided by, I'm going to put that 25 out the front for good measure. 25 r6 and 6. Okay. Now we're at a position again where it's up to you how you want to simplify. Sorry about that. I accidentally wrote, that should be positive. He's happy now. There we go. How you want to simplify, whether you would like to cancel things out, that's what I'm going to do. All right, so I've got n to the 12 and n to the 6 here. So that means I've got 6 n's left on top. I've got r squared on top and r to the 6 on the bottom, which means I've got 4 of those left on the bottom. And I'm now going to also have to combine my m terms, my m bases, m to the 9, m to the 4. All right, so they're going to add together. So that will give me 8 m to the 13, n to the 6, over 25 r to the power of 4. And that's how we're going to get through something like that together. All right? So, whatever way you do approach a problem like this, we should still end up, no matter what, with the exact same answer. Now, I want you to have a go at this question here. It's very similar in that it's a bit clunky. There's some negatives in the wrong spots, and there's even a negative here. Have a go at that one. Send me a working, upload to OneNote. The answer I got for this one was PQ squared on 2. Let's hope you get that too. And from there, I want you to work on these from exercise 3F, where question 7 is definitely a little bit more challenging than the others. All right? Any questions, please email me. Thanks, guys.